Every measurement has some uncertainty. For instance, the length of this eraser is 3.7 centimeters plus or minus 0.1 centimeter. This plus or minus 0.1 centimeter is the uncertainty, a measure of how much we don't know about the true value. The smaller the uncertainty, the more precise the measurement is. In the macroscopic world, there seems to be no limit to how precise we can make measurements. However, in the quantum world, things work differently. Position and momentum cannot both be precisely known at the same time. The more we know about one, the less we know about the other. Here's an analogy to help illustrate the principle. Imagine we take two snapshots of this moving tennis ball. In the first case, we know the position of the tennis ball precisely, but we have no idea about its momentum. On the other hand, a longer exposure would reveal some information about the tennis ball's momentum, but now we lost track of its position. This is the essence of the Heisenberg Uncertainty Principle, which has the following mathematical form. Delta x is the uncertainty in the position, delta px is the uncertainty in the momentum along the x direction, and h bar is Planck's constant. It's a very, very small number. According to the principle, no matter how precise you try to measure both the position and the momentum simultaneously, there's always going to be a fundamental limit to that precision. It's worth noting, though, that unlike the case of the tennis ball where the uncertainty was due to limitations in our measuring instruments, the uncertainty here is an intrinsic property of the quantum system. But what does this all have to do with the diffraction pattern? Well, light behaves as particles called photons. As we narrow the slit, we pinpoint the position of the photons more precisely. Delta x decreases, but according to the uncertainty principle, delta px must increase. This means that some photons gain more sideways momentum and spread out at larger angles, resulting in a wider diffraction pattern. So diffraction isn't just a wave phenomenon, it's a direct consequence of quantum uncertainty.